So today we are going to look at graphing and writing equations for word problems. So we're just going to look at a couple examples. So this one says, as you stop your car at a traffic light, a pebble becomes wedged between the tire treads. When you stop, the distance of the pebble from the pavement varies I cannot say that word for the life of me, so I'm just going to skip it, with the distance that you have traveled. By the way, this word actually means it could be a sine curve or a cosine curve. The period is 1/2 second. Assume the diameter of the wheel is 24 inches. So it says sketch a graph of this function. Okay, so when you do these, I just always start something that looks like this. So let's just look at our information that we have. So it says the period is 1/2 second. So the period, remember that's how long it takes to do one cycle. So this is at 1/2 second. So that means halfway between there is going to be a 1/4 of a second. Okay, so we have that much. It says that the wheel is 24 inches. So that means if you have your rock that's lodged into your wheel, the highest that your rock can go is going to be 24 inches. So we know that's going to be our highest number. And then think about it, the lowest the rock can be is back with the ground. So we have the highest and we have the lowest. So the lowest point is 0, the highest point is 24. We know that one cycle occurs in 1/2 second. Okay, so now, okay, so if you're starting here, and then you are going to end here, and you know that it's going to go up to 24, so that's going to be halfway. And if you connect them, you're right here. And then it would keep going. Okay, so there's a sketch of our curve. So now it wants us to write an equation for the function. Okay, so the first thing, the cool thing with these is you can actually write a sine or a cosine curve. So we're going to do one of each. So we're going to do cosine first. So y equals, we know we're going to have cosine. So the first thing, our amplitude. So actually, before we do the amplitude, let's go over here and do our y displacement. So remember, your y displacement is going to be at your midline. So if this is at 0 and this is at 24, your midline's at 12. So that means we went up 12. Okay, and then our amplitude goes from the midline to the highest point and the midline to the lowest point, which is also 12. Okay, then the stuff in here is usually the most tricky. So if we are doing cosine, think about it. Cosine, it starts high and then it goes O and then low and then O and then back to high. So this is a negative cosine curve because it starts low. So this is going to be a negative 12. Did it shift left or right? No, because it's starting right here. So then we just need to figure out our b value. So b, remember, is going to be 2 pi divided by your period. We know our period is 1/2 a second, so b equals 2 pi divided by 1/2. Same as multiplying by the reciprocal, so b equals 4 pi. So 4 pi. And he's kind of off in no man's land, so I'm going to do plus 12. Okay, so there we have one of our equations. So now let's say we wanted to write it as a sine curve. So some of the stuff is going to stay the same. So the amplitude will stay the same. So we know we have 12, we have sine, and we know that this 12 is also going to be the same. So now we have to figure out, okay, so with a sine graph, your sine graph starts at O, or it starts at your midline. So we need to take this point and scoot it over this way. So this right here, if this is at a fourth, this is going to be at an eighth second. So we need to take this graph and shift it over 1/8 of a second. If I do that, then this point will be here, and then it'll be a normal sine graph. So we are going to take, oh my gosh, in this first one, sorry, I got really distracted. X, don't forget your X in there. Okay, going back down here, so we have 12 sine, I don't remember what I was talking about. Oh, we're gonna move this back. So we need to take, our B value is gonna be the same, sorry, distracted. So that's 4 pi x, and then minus 1/8. Okay, so if you notice, I put parentheses around this whole thing. So pretend I got rid of this. What's that going to graph? Well, that's going to graph an amplitude of 12, a y displacement of -8, and a b value of 4. Okay, that's not what we want. So our parentheses are actually in the wrong spot. So we actually need parentheses around this, because this -8 means we're moving our graph to the right 1/8. Okay, but then you also need parentheses around this. So like this is saying you're taking the sine of all of these outside parentheses, and then the inside ones are talking about your phase shift. So now if you give me 1 second, I can show you on our graph. I think this will work. I won't know until after I'm done. But so right now you should be able to see a red graph. So the red graph, that was our cosine graph. Notice how it starts at 0. It goes up to 24, which is what we want. And then it takes a half a second to complete. So this was our sine graph. So if I turn that on, notice how it's in the exact same spot. Okay, so let me get rid of that. Sorry, if you couldn't see it, I'm not sure how to fix that. And I sounded crazy when I was talking, but okay, get rid of that, get rid of that. Okay, so now you should be able to see my paper again. And we're gonna do another problem. All right, so now we are gonna do this water tide problem. Okay, this time it says, suppose that you are at the beach at Port something, Texas, at 2 p.m. on March 19th. The tide is in, so that's when the water is the deepest. At that time, you find the depth of the water at the end of the pier is 1.5 meters. So I'm just going to write that down. So it's the deepest at 1.5 meters. At 8 p.m. the same day when the tide is out, so tide out, I would assume means it is the most shallow. So shallow is at 1.5. Oh, wait. At 8 p.m. the same day the tide is out, you find the depth of water is 1.1 meters. So this was at 8 p.m. and this was at 2 p.m. Okay, so assume that the depth of the water varies, that word I can't say, with time. Okay, so the first thing it wants us to do is to sketch a graph. So I start with this. So we know, so it starts at 2 p.m. So you have to make sure when you're dealing with time, you either start at noon, which is 12 p.m., or you start at midnight, which is 12 a.m. Since this is 2 p.m., I'm going to start this at 12 p.m. So that's at noon. And then we have 2 o'clock. Actually, I'm not going to do that. Yeah. So it's the deepest at 2 p.m. So let's say this is 2 p.m., 2, 4, 6, 8, 10, and back to midnight. So this is 12 a.m. Okay, so at 2 p.m. it's the deepest at 1.5. So here we'll put 1.5, and that's when it's the deepest at 2 p.m. So we can go ahead and we can put a point here. Okay, it's the most shallow at 8 p.m. So 2, 4, 6, this is 8 p.m. and that's at 1.1. So notice how my scale doesn't match. That's okay. As long as you have these numbers correct, you're good. So that was 6 hours. So, and that's just from going high to low. So to go back to high, we need another 6 hours. So 8 p.m., 10 p.m., 12 p.m., that's only 4 hours. So to get to 6 hours, we need to be at 2 a.m. And here it will be high again. Okay, so, and then I'm actually going to backtrack. So 12 p.m., 6 hours before 2 p.m. is 8 a.m. So here's 10, here's 8. So here's another low right here. Okay, so we can, so there's our sketch. Okay, so now we need to write an equation. So we're going to do the same thing that we did on the last problem. We're going to do sine and we're going to do cosine. All right, so let's see here. So the first thing I'm going to do, if this is 2 p.m. and this is 8 p.m., halfway in between that, we're going to get rid of these ones. And we'll get rid of these ones. Could have kept them, but I don't want to have too much writing when I'm trying to show you this. Okay, so think about it this way. Let's pretend I get rid of this. If this was your starting point, this was your middle point, and this was your ending point, this is similar to having something here. So if this was at 2 a.m., and this is at 8 p.m., and then this is at 2 p.m., what's halfway in between 2 p.m. and 8 p.m.? So if you subtract them, it's 6, half of that is 3, so 3 hours. So this is 5 p.m. And this add 3, this is going to be 11 p.m. So here is one cycle from high to low to high, and we have our 4 dashes in there. Okay, so now let's do cosine first again. So we have cosine. So we will have y equals cosine. All right, so let's start with our y displacement. So we have to find our midline. So our midline is halfway in between 1.1 and 1.5. So that's going to be 1.3. So midline is at 1.3. So we know we went up 1.3. Then let's look at our amplitude. So our amplitude is from 1.3 to 1.5, or 1.1 to 1.3, which is 0.2. So we went up 0.2. Cosine starts high. So high, O, low, so it's positive. So let's figure out what our b value is. So b value equals 2 pi divided by your period. The period, so it goes from 2 p.m. to 12 a.m. That's 12 hours. So we can do 2 pi divided by 12. 2 divided by 12, so that's going to be pi over 6. So this is going to be pi over 6x. And then we have to talk about a shift. So we want this to start at our y-axis. So right now it's at 2 p.m. We want to move it to 12 p.m. So to scoot it back, we're going to subtract 2. And then we have to put in our parentheses. So this is for the phase shift, and this is our outer parentheses, so it knows we're taking the cosine of all of that. Okay, so now let's do a sine. So we are going to have sine y equals, so the amplitude will stay the same. We'll have sine, and we will have plus 1.3. Our b value is also going to be the same, so pi over 6. Okay, so now our sine graph starts at the midline. So our midline is here. So, boy, so this is because my rough sketch is very rough. It's actually right here is where these two are supposed to cross. So it should be like this. So we are at 5 hours difference. So if we want to scoot it back, we're going to subtract 5. So this goes in your parentheses. Oh, and then I need, oh shoot, I forgot to write x. So we have x minus 5, like that. I'm going to pause my video so I can show you on a graph that they are the same. Hang on a second. Okay, you should be able to see my screen again. Okay, so this is the equation we came up with for the cosine. So if I turn that on, it looks like this. So our high is at 1.5, our low is at 1.1, so that's good, and it's happening at 8 p.m., so we have that. If I turn this one on, it should be the same. Ooh, and it's not. So, do you notice what's the difference? Well, one of them is reflected. So if you go back to go back to this, if we look here, we notice that it is starting, our graph is starting higher. So it's starting higher and then it goes up and then down. So let's go back and see if we can figure out which one's right and which one's wrong. So it's starting high and it's going higher. Okay, so the red one, this cosine one's correct. So our sine graph is wrong. So let's go back and look. Oops. This one. Okay, so why do you suppose this one is wrong? Okay, so you have to remember sine goes O, high, O, low, O. And if we look here, we scooted this back to here. Well, that's going low first. So it starts at O and then it goes low, but we wanted it to go high. So that means that our sine graph is going to be negative. And I am assuming that if we go back to this and I make this guy negative, it is exactly the same. Okay, so you have 3 of these problems for homework. And then there's going to be some solving. So the reason we are doing these types of problems is, oh, let me go back to, sorry, okay. So the reason we're doing these types of problems is after you write an equation and after you graph, a question you could ask would be, what is the depth of the water at 4 p.m.? So what you could do is you could take that 4 p.m., plug it into your equation and solve. So you would graph it, you would make your equation, and then you would solve. So instead of having you do all of the problem together like that, where I think it'd be really easy to make a mistake, we're going to split it up. So you'll have to graph a sketch, make an equation, and then after that, we will give an equation to you, and then you solve it. So the solving part's going to be on Khan Academy. And that is all for today.